Hi, everybody. It's great to do this. Thank you, Robert, and thank you, everyone from Alliander who's made this possible. I see a lot of folks on this call, some I know and some I don't. So for those who I don't know, I just wanted to take a really quick moment to set a context for GXF and how critical and important it is in our ecosystem. The first thing is that within the Linux Foundations, one of the things that's so powerful about what the Linux Foundation provides is the ability to have a pre-competitive environment. In other words, that people can come together and not violate antitrust because of the transparency. And that is one of the most important reasons that large companies and small companies and people work together. LF Energy, is really, the vision is that the grid of the future is composed of loosely coupled systems that are resilient, manageable, and observable, combined with robust automation. The digitalization of energy enables engineers and markets to make high impact changes frequently and predictably within minimal toil. And I think that all of you are here because you recognize that that is true. Our mission is to accelerate the energy transition by fostering and sustaining an ecosystem of open source, vendor neutral projects. We democratize state-of-the-art patterns to make these innovations accessible for everyone. And so that's what that's about. And that's, one of the things to set a context for GXF, the Grid Exchange Fabric, is to recognize over the summer, and then in the last 6 weeks, we have had an architectural group working, and there have been anywhere from 20 to 40 people have been engaged in this process of actually working to identify the domain-specific architecture for energy that is harmonizing high, medium, and low voltage, and also harmonizing generation, aggregation, and distribution and transmission, and behind the meter. I'm going to just take a second to show you the architecture, but the LF in LF Energy stands for the Linux Foundation. And we are the world's dominant open source platform. I don't know about that word, but you might want to change it. But we have 100% of the supercomputer market, 82% of the smartphone market, 90% of mainframe computers, and so this gives you a sense of the scale and scope of the Linux Foundation. But we also represent 232 open source projects, representing 40,000 developers. And the importance of this is that the Linux Foundation is you all. And the reason why we're able to do this is because people are willing to and able to contribute to LF Energy. And the projects are open to anyone, the software is open to anyone, but what makes the community work is kind of the virtuous circle. It's the ability to not just take, but also to participate and be a part of. And so it's an open community. And, and what we're seeking to do is alleviate the risk and stagnation of going it alone. So this summer, everybody broke apart. There were a small group that looked at end users of taking these 5 buckets of customer market, system management, acquisition and control, asset management, and shared. And what you're seeing here is basically a taxonomy. And it's a taxonomy for the functional architecture of the grid. And the reason why I'm showing it is because I want you to see where the projects are and where Grid Exchange Fabric sits. And we believe the Grid Exchange Fabric is a critical contribution to the grid of the future. And it's not that the software is perfect, and so you look at it, I mean, it may be, and Robert can tell us why it's perfect, but like anything in life, we have to invest in it to bring it to, really its full fruition. And so for that, I'm very happy about Grid Exchange Fabric and the work of Robert and all the teams. And I am going to, let's see, pass this off to Robert. So hopefully this sets some context. This is my email. Feel free to reach out to me. And we're always here for you, Jeffro and I, to help make LF Energy grow and be healthy and safe and integritous. And I hope you all are all well and enjoy the webinar.
75 of them can be used towards payroll, all forgiven.
Thank you.
Okay, thank you, Shuli. Can you see my screen now?
Yeah, it looks like we've got the sort of presentation view.
Okay, very good.
I mean, we can see the next slide thing on the right and everything.
Oh, that's not the one.
I guess the presenter's view is what I was trying to say.
Thank you.
Mm-hmm.
This is better?
That's perfect.
Perfect. Okay, thank you, Jeffrey and Shuli. Well, thank you for the opportunity to present our Grid Exchange Fabric platform to the Linux Foundation energy community. And of course, we hope that you all gain interest in the platform and will participate in the development in the future. That would be a nice thing. Like Jeffrey just said, if you have any comments or questions during the presentation, put them in the Q&A box. And Jeffrey will, we will answer them at the end of the presentation. And if they are really urgent, he will interrupt and we can answer that right away. So first, short agenda. What will this presentation be about? I will start with a short introduction. Why do we do open source? Why does a company as Alliander do open source? What are the key challenges for utility in relation to the devices in the fields? Then I will elaborate on GXF. What is it, and how is it architecturally set up? I will step into some use cases, how you might be able to use GXF for your own purposes. Show you the roadmap. Where are we going to with GXF right now, and what will we do in the near future? And finally, we will get to the questions, if there are any, and hopefully I can answer them. First, short introduction. I'm Robert Tusveld. I'm an architect at Alliander. I have 25 years of experience in software development, and for the last 4 years, I've been working at Alliander. And Alliander, it's a network company, a holding with several other companies, and one of those companies is Alliander. Alliander is the largest distribution system operator in the Netherlands. Is responsible for a regional distribution of energy, such as electricity, gas, biogas, and heating. To visualize it, on the map on the right, you see a map of the Netherlands, and in green and orange, you can see the area that's the responsibility of Alliander for the distribution of energy. So this will give a bit of context who's talking to you. Why should we use open source? We encourage collaboration within the development needs, and we're convinced that an open approach to software development will boost innovation. And by boosting innovation, it will also save us development time And in the end, also, it will cut the cost and come to quicker and better realization of our projects. In the current market, we see that most companies think that they are very special, and that their software solutions should be very special. But in fact, we're all utilities, and a lot of processes are similar. And I think the use of standards and open standards will only improve this. So for the parts that are similar, why not use open software, use open standards, and this will really increase the development speed of the projects that we are executing. And I think that the more standardized software we develop and we use, the better and more simple the solutions are that we're creating. And well, you get in some kind of continuous improvement flow, because simple solution means reduction of complexity, which means it's easier to develop new software, will lead to faster time to market, and eventually will save us cost. So the use of open source is really a step forward for us. And what is the vision of Alliander for this? The scope of the open source strategy of Alliander is in the first place about software. In the future, we might think about open source, open hardware as well, and designs. But currently, we're just thinking about using open source software. Primarily, the open source approach will result in more speed in the development of the software, and will improve our innovation power by working together with other parties in the industry, and use the experience of all those different parties to improve our products. Our company is funded by social money, and therefore it's appropriate to give the innovations that we've created back to the people and to the society. And with open source software, we're able to give something back to the community. And we believe that an open source approach will lead to better architectural choices and better quality of the solutions that we are building. And this will also improve reusability and adoption of the developed software. And in the end, what is it about? We want to well, gain business value and improve business value. And we think that using open source software and combining the knowledge of our company together with other parties in the industry, we can gain more business value. And how do we think to do that? Well, we want to start small and improve continuously. And we want to do it together with the community, together with other parties in the industry. And to do so, we created an open source program office within Alliander, and that will support and help the teams within Alliander to create open source software and contribute to the open source community. So that's very important to get the open source concept and ideas be handled and be well, the belief that it's the way forward become active within our company. But what are the challenges within the utilities world? We have on one side, we have a conservative world, which is an infrastructure of smart devices, which is are devices from all kinds of vendors with all kinds of protocols, old protocols, new protocols, and all these devices have a pretty long lifetime, Some have a lifetime of a few years, and some even from decades. And on the other side, we have a fast-changing and fast-moving IT world with web applications, even smartphone applications, but also services in the cloud, and well, it's very fast changing, and it's very fast developing. And then we have a desire from an IT point of view to monitor these devices in the field. So we want to see the status of the light sensors. We want to do fault detection. Want to see information about electricity use, power quality, temperature, network load, all kinds of things we want to monitor in the field. And on the other side, we want to be able to control and steer those devices. So we want to be able to remotely switch the devices on or off, do some scheduling for decentralized actions, do all kinds of things like configuration management, firmware updates. We want to do that remotely. And what are the key challenges in this field? That there are pretty high barriers, and there are long lead times for changes. So if we want to roll out a new type of device, or if we want to change an existing device and add functionality to it, it is very difficult and very, very time consuming. And besides that, there's also a high maintenance effort, because there are many vendors, and most of the times those devices have their own set of configuration tools with them. So you need a lot of knowledge of specific hardware and software to be able to maintain them. And we see that there's little flexibility due to vendor-specific roadmaps. So we as customers are not in the lead when creating a roadmap. No, the vendors are. So we desire specific functional changes. We need to hope that the vendor is likely to implement those. And we see as challenge that most solutions are within a certain domain. So cross-domain solutions are very difficult to implement. So what would be the goal then? Or what would we like to achieve? We want to be able to improve the speed of deploying new innovative devices in the field. So make it easy well, to deploy these devices. We want to retrieve existing data from the field and use it for all kinds of purposes. For example, for analysis purposes, do predictive maintenance or fault analysis on this information, and use it also within other domains than the one that we initially created it for. So we want to, in fact, create an independence between the infrastructure on the one side and the fast-moving IT world on the other side. And on the other hand, we want to create independency from the specific vendors and their closed solutions. So we want to be less dependent on the vendors. And on the same time, we want to increase the control on the future development of the solutions. So be in control and even be part of the solution and of the development to build those solutions. And what is then the answer to all these challenges? That is GXF. GXF is a communication framework to interface between the IT applications on one side and the smart IoT-like devices in the field. You have one functional interface for all the types of devices, independent of their protocol and independent of their supplier. The solution must, of course, be open source, should support different types of functional domains, should use standardized open protocols, and should be extendable. and it should also be independent of the communication standard being used. So you should be possible to use all kinds of communication channels that are available and that are necessary to communicate with the specific devices. So in the end, you want to have one middleware solution for all your IoT devices communication to all the devices in the fields. And if you think this is a good idea for us, well, I will tell you more about it, but you'll be happy to join the open source development of GXF. So what is GXF? GXF was formerly known as the Open Smart Grid Platform. It was developed a few years ago in 2014 for Alliander. And the first use case that we created was for our public lighting solution for Alliander in the Netherlands. Besides public lighting, we also created different domains, and some we have created as a proof of concept, and some were more mature solutions. In the center, we have some generic functionality available, which is relevant for all domains, for all devices, for all protocols that they speak. And this functionality, you can think about things like device management, firmware management, organization management. Authorization model is part of the generic functionality of the platform. And the main design considerations that we used creating the Open Smart Grid platform and now the GXF, the Grid Exchange Fabric, were it's extremely scalable. The infrastructure can be highly available, and the software should support that. It is a very secure solution because it is a critical infrastructure managing the energy grid. It should be very secure. It should also be a generic design. So it should be easy usable for different use cases and for different domains. And we don't want any vendor lock-in to take place. So we want to especially implement open protocols and industry standards. Those are the protocols that we want to be using. So when we go to the architecture of GXF, it has a layered architecture. And this architecture consists of several layers. The top layer is the application integration layer. This API layer is divided into functional domain components, and they are linked to a specific functional domain, which are in the layer underneath. There is an authorization as part of GXF, and authorization can be set per functional domain. So it's possible to have an organization only having access to specific functionality in one domain and not being able to access functionality in another domain. The messages between the layers, they are sent via message queues. And in this case, the information from the application integration layer to the domain layer are sent to domain-specific message queues. The interfaces, the services that are available on the application integration layer currently, they can be synchronous or asynchronous. The most of the synchronous calls are calls that will just will just go into the platform and will not go towards a physical device. And if we need to create a connection to the specific device, it's most likely to have an asynchronous call. In case of an asynchronous call, we will return a correlation ID, which represents the specific request. And you'll be able to use that correlation ID for traceability. And later on, if the result of the request is present, you'll be able to request the return values as well. In the layer underneath, it's the domain logic layer. And this layer contains the translation of the functional values into a generic internal format, and vice versa in case of the results that are being sent back to the requesting application. This is a pretty thin layer, which consists of translations, and for the rest, this is mainly a stateless layer. GXF is in fact completely stateless, which means that every request contains all information that is needed to execute it. And this is extremely important for the scalability of the application. I will come back to that later on when I step into the details of the scalability. And then we have the core layer of GXF. This is the central part of the platform. The core functionality that will be used for all the devices, independent of their protocol, is available in the core layer. And the functionality that is available are functionality like device management, time synchronization. There's firmware management is present in the core layer. There's a workflow engine. You can see the device installation services there. There's a scheduler, and you can monitor the status of the devices. And an important part of the core layer is the routing of the specific commands that will go to the device and have to be translated to a specific protocol. So the core layer knows which protocol is being used by each device in the field, and the core layer will handle the routing of these commands. And then we have the bottom layer of GXF, which contains the protocols. Based on the protocol, the information from a specific functional request is translated into the specific protocol messages. Currently, we have several protocols implemented. We have the IAC 61850 implemented. We have the Open Streetlight Protocol, OSLP, implemented. We both use them for public lighting solution. But the 61850 can also be used for other communication to substation devices. We have a DLMS COSAM protocol implemented, that's for smart metering. And we have the ISC 6870-5-104 implemented for a first version of this protocol. We have it running. And we have an MQTT implementation present, which is also a first implementation for a specific proof of concept that we're building on right now. And it's pretty flexible, so you can add protocols if you need them, or if you have the desire to create another protocol based on industry standards. Feel free and add this protocol to the stack of existing protocols. What I said a little earlier is in between the layers, we use message queues to guarantee the scalability of the whole platform. And how does this concept work? The queues that we're using are transactional. which means that a request is handled from the queue, and it is only committed and the transaction is finished when the whole processing of that request is successful. If something goes wrong, the request will stay in the initial queue and will, on a later moment, be handled by another worker who will pick up the same request for a second time and try to handle it and process it again. The messages are also persisted in the queue. So if ActiveMQ fails and the system reboots or something, all the existing requests in the queues will stay in the queue. So after a restart, the workers can proceed with the processing of those requests. To be more scalable, and if you want to use GXF in a multi-server situation or a multi-data center situation, you can also use a clustering of ActiveMQ and a clustering of databases, of course, to have the information be available in all places at the same time. With this concept, the messages will never get lost, and we guarantee that all messages that are being handled will be handled successfully. And by using this concept, we get a very flexible situation, and you can scale up and down specific layers. You can scale up and down servers. You can add servers at runtime. You can create a cloud-hosted solution where you have data centers in the different availability zones. So you can, based on your needs, based on your infrastructure requirements, you can create the infrastructure that can support that. And GXF is as flexible as you need it to run it in any kind of infrastructure. Then we also have a lot of security built in GXF. GXF is built, it's secure by design. It's a really important design in the design of GXF. And through all the layers of the architecture, you find security measures being taken to guarantee the desired level of security that is necessary. We use the concept called zero trust. GXF doesn't trust its own components, so we do an extra trust by adding mutual TLS in all communication. So the communication to and from the devices is encrypted. The communication to and from the applications is encrypted. If we transport a key or a certificate through the layers of GXF, it will be encrypted. We can add infrastructural measures as well. So we can add DDoS protection, IP whitelisting, additional VPN tunnels, firewalls, everything that's needed to make a secure solution which well covers your needs. And in the end, at every major release of the software that we plan on having, we do a security audit by an external party, and we've done that a few times in the past now. And this will guarantee that the solution is as secure as possible. So if we recap the things I just told, the solution it's multi-secure, secure throughout the architecture, throughout all layers of the architecture, and also in the infrastructure and in the protocols. But that's protocol specific. some protocols have a lot of security measures incorporated in the protocol. Others have less, and we try to maximize the security measures within our usage. The solution is multi-flexible and extendable, so you can add domains as you wish, add protocols as you wish. You can have several applications on top of the different use cases, and these applications can reuse the functionality that is available within the platform, within GXF. You can add communication channels and configure it within the core layer of GXF. So the protocols are configured per device, and within the core layer, the information that's necessary to create a connection to communicate with a device is present. So for one device, we know how can we communicate with this device, through what communication channel or through what address. And on the other hand, we know what protocol does this device speak, and what do we need to communicate with this device. And finally, the solutions that can be built on top of GXF can also be multi-tenant. So you can have a multi-owner solution. It's authorization based, and it's also you can only see the devices that you are allowed to see. So if you have no authorization to see a specific device, and you're not the owner of that device, you will never get the information through the layers of the architecture. And that's authorized. The authorization model is also available through the different layers of the architecture. And in the end, you can create a multi-solution. So you can use the same platform, the same GXF instance for several solutions. But of course, this depends on what do you want to achieve and what are the requirements. And based on your security requirements or your performance requirements, you can decide what infrastructure do I need, and can I combine more solutions on one instance of the platform, or do I want to have a separate instance of the platform being used for every specific solution. So that's the flexibility that you have, and it's in the end an operational choice that you have to make. What you see here is on the right side of the picture is an overview of all the modules within GXF. And if you have a specific solution, you don't have to select all the building blocks from the platform. So you can, in this case, we have a solution that will only use some functional domains and some protocols in the underlying layers that are needed for this solution. And when we go to the public lighting solution, you can see we are using, again, different building blocks from GXF, and we have different applications on top of it. So depending on what you need, you select the building blocks that are necessary for this specific solution. So what kind of use cases, well, can you think about? The one I mentioned earlier was the flexible public lighting solution at Alliander. This project was about an old technology, ripple control, and we have replaced this one by using smart devices. These smart devices, we used devices of different suppliers, and the devices even use different protocols to communicate. So with this solution, we don't have a vendor lock-in. we have more than one supplier, and we use different protocols to communicate with the switching devices. But on top, we have 3 kinds of applications for the end users, and they all speak the same language, the same functional language to interact with GXF. And in fact, you can have a application to switch the light on, and you interact with the web service application integration layer, and call a web service that says, turn the lights on. And that call will eventually be translated into different protocols and into different protocol messages, and they will be sent to the different types of devices that we have in the field. And both devices will eventually switch on. And in this specific use case within Alliander, we have 3 applications. One application is an installation application that is for the engineer in the field who does the installation. Then we have an operator application for a different user group, which are the operators of the public lighting solution. And we have a third application that is used by the municipalities who are able to control a specific part of the functionality of the switching devices in their municipality, so which are under their responsibility. And for this specific solution, we have an on-premise infrastructure. This was based on the requirements that we had when building the solution, but you can imagine that you could also do this in a different setup, maybe cloud-based on AWS or Azure, and have a whole flexible solution in the cloud with auto-scaling groups separated into different availability zones. And into the future, we plan on using Docker containers as well, and Kubernetes. So depending on your needs, depending on your infrastructure requirements, you can select the correct infrastructure that suits your needs and suits your requirements. And when we position GXF within the Alliander landscape, we envision that there might be more than only one instance of GXF. Currently, we have an instance in the OT environment with a very secure and a very secure environment. But you can imagine that when you want to use cheap and easy to use sensors in the fields, it's also possible to use a version of GXF and host it in the cloud. This will make it very flexible, and you can also, based on your requirements, put another instance within your IT environment, so you can have more control on the specific environment where the applications or where the platform is running. So these are different concepts of how you can use the platform, how we see it within the Alliander landscape. And beginning of this year, we did a hackathon. The hackathon was organized under the flag of LFA, and we did it together with RTE. RTE is a French TSO, and with Tenet, a TSO in Netherlands and Germany. And together with Alliander, we thought of a use case in which we could combine our different products and our different set of knowledge to create an end-to-end solution, which, well, seems to be very relevant for all of us. And central in this design, you see GXF as the communication platform, the middleware that's retrieving the information from a transformer from the field. GXF communicates with the transformer using 61850 as protocol. And the information, the stream with power information and temperature information is then transformed into a Kafka message using Avro format and a sim modeled stream, and publish it on the Kafka bus. This information is then centrally stored, and the same information is being used on the left side to display the real-time information on a display, an overview display. And the same information is then used for analytics and for an analysis report being created. And in the end, the analytics results in a alert that there needs to be predictive maintenance. There's a predictive maintenance alert that we might send someone to the transformer because we think something is going to happen in the near future. So this is a real example of how you could use GXF in combination with other tools and other analytics tooling that's already available within a lot of companies, and come to an end-to-end solution and a use case that's really suitable. So during this hackathon, we combined the knowledge of RTE, Tenet, and Alliander, and we managed to create in a 3-day hackathon an end-to-end solution, and we were able to demonstrate it in a presentation. So that was really successful. Now we come to the roadmap of GXF. So what are we currently working on, and what will we do in the near future? So currently we are working on a few things. On the left in blue, you see the things we are doing for the Linux Foundation or related. So we have the webinar, we're going to improve the documentation, we're creating a roadmap, and we'll communicate that to the members of LFE and the GXF community. We will additionally do license checks to see if all the licenses used within our software is according to what we want to have the license to be it. We are implementing ECCLA, so that's a contributors license agreements tool provided by LFA. And we're going to look at the Dockerization of our platform. And as I told earlier, we're currently developing the 104 protocol, including a simulator, and the MQTT protocol, including the simulator as well. And in the light greenish blocks, we have room for even a new domain or new protocols. So that's something that could be created by the community. So hopefully you can be part of that. So coming to visualization of the roadmap in time. Well, as you see here, currently we're working on the Kafka interface, on the MQTT adapter, and we start building on Dockerization. We do the webinar currently, and we're going to publish the roadmap to the community as well. Hopefully this gives a good overview of the work we're currently doing. And there's also a place for the community to pick up additional work. So I added 2 potential protocols, which might be interesting to add to GXF as new protocols for the future. There's a lot of information about GXF on the internet. First, we have a GitHub location. There you can find our open source software. It's github.com/OSGP. There's a lot of documentation, documentation.opensmartgridplatform.org. We don't have the complete translation or didn't relabel it to GXF yet. We will do that in the future. But currently, you will find the name Open Smart Grid Platform on a lot of locations, and they will eventually change. But currently, if you read Open Smart Grid Platform, just say speak up loud and say GXF, then it will be the same. And we have our community website, www.opensmartgridplatform.org, for a lot of extra information and potential use cases that you might be, where you can use OSGP for, GXF for. So thank you for your interest. And I wonder, are there any questions that you might have?
Thanks, Robert. That's very interesting. A really interesting presentation. We do have one question from Audrey. What does tariff switching mean?
Tariff switching is, at least in the Netherlands, we have a low tariff and a high tariff, and those are also switched based on a schedule. So in the evening and in the weekends, you have a lower rate for your electricity, and that's switched by a scheme. So that's tariff switching.
Okay, great. Looks like a few other questions coming in. Audrey says, like a time of use tariff, on-peak rates and off-peak rates, is that similar?
No, I'm not familiar with that. Sorry.
Okay, I think that's I know that in the U.S. the tariffs are usually rated as being on peak and off peak.
Yeah. Okay. And that I think that's the same. We have a low tariff and a high tariff, and I think this will change in the future. It will become much more dynamic. And with our solution that we created, we are able to handle all kinds of changes and being flexible with the tariff as well.
Okay, great. One other question coming in which language is the platform created, and can you use other languages to interact with the platform?
The platform is created in Java, and it's enclosed on the top with SOAP web services. So you can create applications in any language. When they can access a SOAP web service, you'll be able to talk to the GXF platform.
Great. And we've got to thank you for your answer.
You're welcome.
So any other questions? Feel free to raise a hand or type it into the Q&A box or the chat window. And I'm not hearing any others. I think maybe you covered everything.
Okay, well, that would be nice. Well, if people have questions later on, please send them to me by email or through Linux Foundation.
Yes, there is a one thing to note is that there is a GXF group on the LF Energy server that lists.lfenergy.org, and anybody's free to join it. Looks like we do have one raised hand. Wouter, I'm going to allow you. I thought I was going to. The interface is acting strangely. So I think we may be, if there's any other questions coming in, so just give people one more second to type. In the meantime, I will post the list server. No problem. In the meantime, I'll post the list server on the chat real quick here. It has this server has the list, the groups and mailing lists for all of LF Energy's projects, including GXF.
Okay.
Okay, well, I think that we are at our time. Thank you very much, Robert, for such a great webinar. And we'll have the recording up soon.
Mm-hmm.
And thank you, everybody, for joining.
Okay. Thank you to everyone, and hopefully we can see you as a contributor to our grid exchange fabric in the future. Thank you.
Perfect. Thanks, everybody.